Hey guys, it's Mr. Wolf here. I'm going to be going over what we went over in class on Monday. So if you were absent, this is a great tool to look at. Also, just in general, if you want a review on projectile motion equations, a great review to go over. And so if you want to go over the concepts of projectile motion, go over that first video. That goes over pages 3 and 5 of your packet. This is more applying those concepts to solving problems. Just really quick, when we have a projectile that's going at a horizontal velocity, it's going to fall through the air and it's going to follow an arc similar to this. But we also know that we could split this up into an x and y direction. And so in the x direction, it's going to be moving at a constant speed. In the y direction, it's going to be moving at an increasing speed due to the force of gravity acting on our object. And so if we look at page 7 of our packet, we have a building, and it is 17 meters high, and there's a pool that is 10 meters away. And we jump off of it going at 6 meters per second. So the question is do we, as we're falling towards the ground, do we make it far enough in that x direction, to either land in the pool or hit the concrete? So how are we going to want to go about solving this? Well, we're going to want to find that distance that we move as we're falling. So that distance in the x direction. So one thing that we know is that this object, remember looking back here, is it's moving at a constant speed. So if it's moving at a constant speed, we're going to use that equation that we know for constant speed, which is going to be distance equals velocity times time. So let's hold that there, but really quick, before I even go into that even more, I'm going to want to just set up all the variables that we know. So I'm going to make this chart right here. All right, x and y. This is my x direction, my y direction. For all of these, I'm going to be finding my initial velocity, my final velocity, my change in distance, my acceleration, and my time. All right, so for my x direction, we know our initial velocity. That's given to us right here. And that's going to be 6 meters per second. Now our final velocity, it's not directly given it, but we could figure that out pretty easily because it's again, in our x direction, we're moving at that constant velocity. So whatever the velocity is here, it's going to be the same as here. It's going to be the same as our final velocity. It's going to be 6 meters per second. Now, that change in distance right here, this is our ultimate goal. This is what we're looking for here. How far did we move in the x direction as we were falling? Our acceleration, that's going to be 0 meters per second squared because we're not changing our motion at all. There's going to be no change in velocity. And our time, we don't know yet. All right, so the fact that we don't know our time, that poses us a problem. So let's look back at our equation right here. In order to find our distance, we have our velocity. It's going to be always going to be that 6 meters per second. But we also don't have our time. So we can't solve an equation with two unknown variables. But let's look at our y component of our motion. And so our initial velocity, well, as this person is jumping, or really not even jumping, running off of the building, he's moving in that x direction, but hasn't fallen at all in the y direction. So our initial velocity is going to be 0 meters per second. Our final velocity we don't know yet, although we will be able to find it. And we know our change in direction. It's going to be negative 17 meters. The reason I have a negative there is because we're changing direction in the negative. We're changing distance or our position in the negative direction. And our acceleration is going to be the acceleration due to gravity. That's the force that's acting on it. So it's going to be 9.8 meters per second squared. We're going to make that negative as well because gravity, the force is pulling us in that negative direction. Now the time. Just like our x component, we also don't know the time right now. But we might be able to figure out the time in the y direction because again, we're looking at this object, this projectile that's falling towards the ground in two different components, but it's still the same object. We're just looking at it in two different ways. So whatever the time is going to be in the y direction, it's also going to be the same in the x direction. So let's see if we could find time in the y direction. All right, well, we're just looking at that y component, that horizontal component. This looks pretty familiar to a free fall problem where we have our initial velocity being 0, our acceleration, and our change in distance. We could solve this basically just like a free fall equation. So we're going to use our free fall equation. Distance is equal to 1/2 at squared, and change in distance. And so we'll just plug in our answers now, or plug in our numbers. And so we have -17 is equal to 1/2, -9.8 times time squared. We're solving for time now. And we're going to get something like 3.469 is equal to t squared. Remember, we have to square both sides. And our time is going to be equal to 1.86 seconds. All right. So now we found our time in the y direction, 1.86 seconds. That's how long it took this person to fall to the ground. It took 1.86 seconds. But remember, our ultimate goal is to figure out the distance that he moved in that x direction, and by using this equation right here. But remember, the time that we found for the y direction is going to be exactly the same for the time in the x direction. It's the exact same object. So now that we found the time using our y component, we could apply this now to our x component. So let's go back to that equation that we had before. Our distance is equal to 6 meters per second times the time. We don't know our distance yet. We have 6 meters per second, but we now have this new time that we could plug in, 1.86 seconds. So during that time in the air, moving at this velocity, we're going to be able to solve how far we've moved. And so solving this equation, we're going to get something that's going to be, our change in distance is going to be 11.16 meters. So that's our change in direction in the x direction. So again, remember, this is what we were looking for to solve this problem, is how far did he move in that x direction? And so he moved 11 meters in the x direction. So he went past that 10 meters. So in this situation, this guy ends up being okay. He falls into the pool. All right, so that really concludes that problem on page 7. If you weren't here on Monday, I'd highly recommend that you go to page 8, try that problem out, and I'll look it over tomorrow. If you the tell to really see that you're understanding this material is if you go to page 9, number 2 on page 9. If you could solve that and you could go about doing that, that's a good indication that you're really getting this material. And then finally, just as a reminder, the homework is due tomorrow. And so even if you were absent and you're watching this video now, you could still at least go about trying the homework. And if you don't understand something, write down, what didn't you get about it? Really quick, I will help set up a problem on on page 8 for you guys. So if you want, you could stop the video and just work on these problems. You can continue watching if you need help setting it up, or if you think you could set it up and then you might need help, come back, watch this part of the video. All right, so a not so intelligent person is, I'm going to move kind of this over to the side a little bit. A not so intelligent person, this is on page 8, is biking towards a cliff when the brakes go out. And he bikes off going at 15 meters per second. The cliff is 18 meters high. And then it's asking how far from the base of the cliff will the person land, and how fast will they be going as they hit the water. For this problem, we didn't really go over too much on this in class, so actually don't worry about doing number 5 for this. Just worry about 1, 2, 3, and 4. So he goes off at 15 meters per second, 18 meters, and it's asking how far did he travel in this x direction. So really this is basically similar to the last problem we just did. So let's set it up quick, and then you guys could go about working on solving it. So our initial velocity, our final velocity, our change in distance, our acceleration, and our time. All right, our initial velocity. Well, it's going to be that 15 meters per second in the x direction. Remember, it's at a constant speed, so even over here, we're still going at 15 meters per second. Since we don't have a change in velocity, our acceleration is going to be 0 meters per second squared. And our change in distance this time is going to be right here. It's going to be negative 18 meters. Remember, the negative is just we're changing direction from here to here, and that's going in the negative direction. And really quick, as I say that, I realize I made a quick error. So I'm going to cross out that 18 meters. That 18 meters, sorry, is going to be in that y direction, right? It makes sense. It's going vertically. So I'm going to put that here. And so that change in distance, again, is what we're going to be looking for. And right now, we don't know our change in time. Let's look at our y component now. He hasn't fallen just yet because he's still on the cliff. This is the split second as he hits off. We're going at 0 meters per second. Final velocity we don't know right now. And our acceleration is going to be that acceleration due to gravity, that negative 9.8 meters per second. Remember, negative because acceleration is pulling downwards in this situation. And finally, that time we don't know. So here's how you're going to go about solving this problem. Reference back to how we did it in the situation right here. Good luck, guys. Again, I'll also be at school early tomorrow, so if you just want to come by, and when I say tomorrow, this is going to be Wednesday. So just come. I'll be at school early if you guys have any questions on this stuff. All right. See ya.